Okay, this is the last one, Math 2, Unit 13, second semester final review, looking at our probability unit we just did like about a week ago. So here we go. True or false? The probability close to 0 means the event is unlikely to happen. That is true. Probability can range from -1 to 1. That is false. Probabilities range from 0 to 1, where 0 is least likely and 1 is most likely. Probability close to 1 means the event is likely to happen. That is true. Probability 100 means the event will be guaranteed to happen. Now, I prefer that was 100%. If it's 100%, that's what they mean, the answer would be true. If it's actually just 100, that's too big, so we'd probably say false, but I believe they mean like 100% chance of it happening is guaranteed to happen. So, it just depends on what your teacher means by 100 or 100%. It's 100 or 100%, because it can only be between 0 and 1. So maybe ask on that one. Number E, probability 50% means the event is equally likely to happen or not happen. Equally likely, that is true, because it's about a 50% chance that one or the other could happen. For this next section here, we have a table, a two-way frequency table, that we have to complete in order to answer the following questions. So to complete this here, we have to do a little bit of math, and you have 105 total, so subtract what you have to find out what you're missing. I'm going to fill in some numbers here. I have 39, I can add those up to 85. I can see what I'm missing here, which is 36. I can see what I'm missing out of 60, which is 14. I can total up this line, which is 80, and total up this line, which is 100. So now my values are in place. I can now work on the fraction part to find my probability. So the first one is ice cream or cake. Well, there are 105 ice cream selections out of 300, and then cake is 85, and that word or means I'm going to add, and so 105 plus 85 is 190 out of 300, and that reduces down to 19 out of 30. For B, I have the first graders given cake. So my given number becomes my denominator, so cake is at 85, so I'll write 85 there. And my first grader, how many first graders are there? There's going to be here the first grader in this column, looking at the cake section, will be 20, given that I have 85. So there are 20 first graders, given that I'm looking in the cake column. That thing can reduce down by dividing both parts by 5. 20 divided by 5 is 4. 85 divided by 5 is 17. The next one, another given. Given that it's a third grader, what's the probability of being popcorn? So here's my third grader. They're at 100. So if that's 100, where's my popcorn number? Popcorn number is here at 12. So the chance of it being popcorn, given that it's a third grader, is 12 out of 100, which reduces down to 3/25, because 4 goes into both of those. The probability of being cake and candy, we can see here those don't ever cross, so there's no chance of getting cake and candy. You have to be a grade as well, okay? Popcorn and a second grader. Okay, so I'm going to look here. Here's my popcorn, and a second grader goes here at 36. So the probability of being a popcorn and a second grader is 36 out of my total number of kids, which is 300. That can reduce down. You can kind of break it in half if you wanted to. 18 out of 150. I could say that 3 goes into both of those. And so I'll actually break that into 2 again. So this becomes 9 and 75. 3 goes in there 3 times, and 25 for my final 3 out of 25 for my reduced form. The probability of a first grader or a second grader. First graders total 80, and second graders total 120, and that of course is out of the total, which becomes 200 out of 300, which reduces down to 2/3. The probability of a first grader and a third grader, again, first grader and a third grader, you're probably not going to be in both grades at the same time, so we would say 0. The probability of it being a first grader or a second grader or a third grader, out of all of them, 80 plus 120 plus 100 equals 300. Out of 300, that's everybody. It's going to be one of those. The answer is 1. And then finally, probably a third grader or candy. Here is our third grader row, and candy is 14. So I have 14 out of, oh, sorry about that. It's not going to be 14 out of that. third grader or candy, sorry, brought this one here. So a third grader is going to be 100 out of 300. The or candy means 60 out of 300. But if I look at the candy column and the third grader column, I have this overlap right there. I don't want to include that number twice, so I need to subtract the overlap number, 14 out of 300. Okay, so be careful about that one because there is an overlap. I have to subtract the overlap right here. So 100 plus 60 is 160, minus 14 is 146 out of 300, and that's going to equal 73 out of 150. So that's a key one for you to remember how to do that one there if there's that overlap that takes place. Okay, down below, we have 12 marbles in a bag. Probability of them, we have 5 blue, 4 red, 3 white. So the probability of a red is there are 4 red out of 12, which can reduce down to 1/3. Probability of red or blue, again, red is 4, blue is 5, out of the whole number is 12, which is 9/12, which can reduce down to 3/4. Probability of a green marble. Well, by blue, red, and white, chances are 0. You're not going to find any, not in the bag. And find the probability of blue or red or white. Blue is 5, red is 4, white is 3 out of 12. 5 plus 4 plus 3 is 12, which means the probability is most likely going to happen because that's all you have to choose from, 1. Clicking on our final page here, we have independent events. The thing with independent, you want to remember between independent and mutually exclusive, is that with independent, you probably are going to have an overlap, like we did in the last little set of problems with the first graders and the candy stuff. So be careful of that overlap. That might mean that we're going to have to do an actual step, which we will. So here we go. The probability of L and M, okay? The probability of L and M happening, we would say that's going to be 0.65 times 0.35. That M means to multiply, and I get 0.21. The probability of it not being M is going to be 1 minus the M value, 0.35, to end up with 0.65. Okay? The probability then we have over here of L or M, okay, they're independent events. I'm going to take the probability of L, and I'm going to add to it the probability of M, but I want to subtract from it my overlap. That is my L and M, my 0.21. So I want to subtract the overlap here because they could cross. I don't want to count that thing twice. So 0.6 plus 0.35 minus 0.21 equals 0.74. So then when we move over here, the probability of it not being L or M, I use that value and I do 100 minus 0.24 to end up with, 0.74, sorry, 0.74, to end up with 0.26. Okay? Key thing there is that overlap because it's an independent event. Number 5, we have decimals again. Probability of it not being R, well, R is 0.25, so we would do 1 minus 0.25. Probability of it not being R is 0.75. Probability of it being R or S is going to be 0.25 plus 0.42 or 0.67. The probability of R and S is going to be 0.25 times 0.42, and that becomes 0.105 for R and S. The probability of not R or S, be careful here, we're looking at this one. Here's the probability of R or S. I'll subtract that from 1 and end up with 0.33 for that one there. Number 7. A coin has a head on one side, a tail on the other. It's flipped 4 times. How many different ways can a sequence of heads and tails happen? So think of it this way. We have 1, 2, 3, 4 coin flips. I can get a head or a tail, 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 which means I have 2 options, 2 options, 2 options, 2 options. Fundamental accounting principle, I multiply 2 times 2 is 4, times 2 is 8, times another 2 equals 16. Okay? So first of all, there are 16 ways that can happen. Now, I want you to complete a list of all the different ways in the sequence of tails could happen. This is kind of complicated, but technically you can get ahead, 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 and ahead, and we can kind of keep doing this here. So you're going to create a list here of the different ways, right? So we can end up with a head, ahead, ahead. We can have a head, head, and one tail. And now I can move that tail through, head, head, tail, head, head, tail, head, head, and then tail, head, head, head. I can have two heads, or two tails. I can have head, head, tail, tail, head, tail, head, tail. I can have head, tail, tail, head. I can have tail, head, head, tail. I can have tail, head, tail, head. I can have three tails. I can do a head, tail, 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 head, tail, head, tail, 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 head, tail, and tail, 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 head. And I can have tail, 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 tail. Let's see if I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I'm missing one again. Let's see. I've got 1, 2, 3, 4, three of those. 2, 2, 2, 2. Oh, here it is. I'm missing the tail, tail, head, head. Tail, tail, head, head. There you go. So now using this information, as sloppy as it might be, it wants to know what's the chance that there's exactly one head. Well, this is my three-tail section here. Three-tail section there, where I can get it in a couple ways. So I have 4 different ways that can happen out of my 16, which is 1/4. What are the chances there are more than 2 tails? Well, more than 2 tails I have, or more than 2, sorry. That's going to be, there are more than 2 tails. So we have 1, 2, 3, 4, and that one is 5. So 5 out of 16. And the chance that there are 5 heads is going to be 0 because we're only flipping it 4 times. Alright, so kind of annoying to do that part there, but I'll let you figure out how you want to graph that, chart that. That's up to you. Last one here, we have a Venn diagram, and we have 50 people surveyed who like oranges and they like apples. It says that there are 22 like oranges, so I'm going to put it on the side for now, and that there are 35 that like apples and 15 like both. I'm going to put the 15 in the middle. First thing I'm going to do is I'm going to do 22 minus 15 to get 7. It tells me how many people just like oranges. And I'll do 35 minus 15 to tell me how many people just like apples. I'm going to combine all that together to say 35 plus 7 is 42. And I know it's out of 50, which means that there are 8 people that don't like anything. And I'll put them over on the side. Now I can answer some questions. How many like oranges only? That's 7. How many like neither oranges or apples? That's 8. And what's the probability the person surveyed liked both oranges and apples? That's going to be 15 out of the 50, or reduces down to 3/10. Alright, that is it for today, and actually it for Math 2 for me. It's been a great time, great year. Hope you do well on your final.